you ever wondered why a forgotten technology could completely change the way we look at artificial intelligence? It seems the next big leap in computing might not be some brand new invention, but actually the perfection of a really old idea. Let's get into it. Yeah, you're seeing that right. 1,000 times. That's not a typo. We're talking about a new kind of chip that scientists have developed, and it has the potential to be 1,000 times faster than the best processors we have today. This isn't just a little step up, it's a completely different ballgame. So, faster than an Nvidia GPU? Yep, you heard that right. This new chip is throwing down the gauntlet, directly challenging the undisputed champions of the AI world. We're talking about the big dogs, like the powerful GPUs from Nvidia. It's a seriously bold claim, and it kind of rewrites what we all thought was even possible. Now, before we get any further, if this is already blowing your mind, make sure you hit that subscribe button for Geo9 so you don't miss out on more stuff like this.
Okay, so how is this even possible, right? Well, the answer is pretty surprising. It lies in a different kind of computing, one that was basically left in the dust during the race for digital dominance. We're talking about analog.
So the core difference between digital and analog is actually pretty simple to wrap your head around. Think about it like this. Digital computing, the stuff that runs literally everything from your phone to the biggest supercomputers, it's like a light switch. It's binary, it's either on or it's off, a 1 or a 0. That's it. But analog computing, that's more like a dimmer dial. It doesn't just do on or off. It works with a whole continuous range of values, like voltage, to represent information. It's just a more dynamic, more nuanced way of doing things.
And analog computing isn't new at all. Its roots go way, way back to mechanical gadgets in ancient Greece. But for pretty much all of modern history, it just got pushed to the side. The problem was it ran into these huge technical roadblocks with things like precision and scaling up, and that's what let the simpler, more reliable digital model just take over and build the entire world we live in today.
So that begs the question, why on earth would we go back to it now? Well, because the digital path we've been on for decades, it's starting to hit a fundamental limit. We're pretty much hitting a wall, and the insane demands of modern tech, especially AI, are forcing us to find a completely new way forward. And here's the problem. Training these massive AI models we have today takes a staggering amount of energy, just an incredible amount. And at the exact same time, we're getting really close to the physical limits of how small we can actually make digital transistors. We just can't keep making things smaller and faster forever. The energy costs and the processing bottlenecks, they're becoming completely unsustainable. This really underscores how urgent this is. To get to the next level of AI, to run more accurate scientific simulations, we need a genuine paradigm shift. The key takeaway here is that we really need something that can go beyond the physical limits of digital computing. We can't just keep improving on the old rules. We have to create entirely new ones. And that is where this all comes together. A team of researchers from Peking University has developed a new analog chip that takes these challenges head on, giving us a potential way around that digital wall. So what this really means is, instead of dealing with abstract ones and zeros, this chip does its computing using a real-world physical property called conductance. Basically, it measures how easily an electrical current flows through its parts, and it uses that continuous, real-world value to perform calculations directly at just unbelievable speeds. And the results? They are absolutely staggering. When you put this new analog chip head-to-head with a top-of-the-line digital GPU on the two most important metrics, energy efficiency and throughput, which is just processing speed, the analog chip isn't just a little bit better. It's in a completely different league. All right, let's break that down. First up, energy efficiency. The research is suggesting this analog approach could be up to 100 times more energy efficient than the digital processors we're using now. That's a direct solution to that massive energy problem that's hounding the AI industry. And then there's that headline number again, a potential 1,000-fold increase in throughput. That's how fast it can chew through data. A performance gain like that could accelerate AI development and scientific research in ways we can't even really imagine right now. If you're finding these insights as fascinating as I do, taking a second to subscribe to Geo9 really helps me keep digging into stories like this. Now, it's important to know, this chip is highly specialized. It's not a general-purpose processor. It absolutely excels at solving these incredibly complex math problems called matrix inversions. You can just think of those as the really heavy foundational math that's crucial for training neural networks, processing wireless signals, and running complex simulations.
Basically, this chip is purpose-built to do the heavy lifting for AI. So, what does this all add up to? Well, a chip that's 100 times more efficient and 1,000 times faster, that's not just a cool piece of engineering. It's basically a key that could unlock a whole new future for artificial intelligence and scientific discovery. Now, think about this for a second. With this kind of power, we could finally start to overcome those physical barriers that are holding digital computing back. We could power the immense calculations needed to train much more sophisticated AI, maybe even AI that starts to feel more human-like. And we could simulate the world's most complex systems, everything from weather patterns to biological processes, with a level of detail and accuracy that's just completely out of reach today. Look, this breakthrough isn't just about making faster computers. It's about fundamentally expanding the boundaries of what we can know and what we can achieve. It really forces us to ask a pretty profound question. What will we create with this power? I mean, with this kind of unprecedented capability at our fingertips, what happens next? So, what's your take on this? I'd love to hear your point of view in the comments below. And of course, if you haven't already, subscribe to Geo9 so you don't miss out on future insights.